Okay, so for the last part of 3.5, we'll talk about the distance from a point to a line. So if you have a point, let's just call that point P, and a line, call it line L. The definition of the distance from the point to the line, it's like the shortest distance. So it'd have to be a segment specifically, and then that segment has to be perpendicular to the line. So it's specifically a segment from the point perpendicular to the line. And then if I want to use that to be able to find the distance between a point and a line in a coordinate plane, here I want to find the distance between my point A, 0, 5. I'll graph that in a second. And then the line y equals negative 3x minus 5. So I'll draw that in my coordinate plane. My x and y axis. A is the point 0, 5. So that's on the y axis. Right here. And then I want to find the distance between that point and the line y equals negative 3x minus 5. So I have to graph that line, start off at the y-intercept, or b. That's negative 5. And then the slope is negative 3, or negative 3 over 1. So I go down 3, right 1. Or, since I'm going to kind of run out of the room at the bottom of my paper here, I can go up 3, left 1. It's the same thing. I'm going to continue that pattern. Up 3, left 1. All these points should be collinear. You should know that term by now. And so since I want a segment, I should erase this so I can actually draw that segment. From point A, 0, 5, that's perpendicular to this line. If it's perpendicular, the slope of this line, I'm even going to label it M, is negative 3, or negative 3 over 1. So then from this line to this point, the slope has to be opposite reciprocal if it's going to be perpendicular. So the opposite reciprocal of negative 3 over 1, positive 1/3. So I can write it like this. Again, that symbol is perpendicular. The perpendicular slope is 1/3. So from this point, I can go up 1, right 3, but that's going away from the line. So instead of going up 1, right 3, down 1, left 3. So it's this segment right here. From the point A is right here to the line, and it's perpendicular because this segment has the opposite reciprocal slope of this line. So we just need to calculate the distance here, either using the distance formula or the Pythagorean theorem. So I have the point 0, 5. You would have to figure out the coordinates of this point. It's negative 3, 4, and then use the distance formula, or I could use the Pythagorean theorem. I should get the same thing. So if I make a right triangle, again, we're trying to find this segment length right here. So I'm going to make this right triangle. This side length is 1. This is 3. Whatever you want to call it. You can just call it C if you want for the distance, or D. But C squared is equal to A squared plus B squared. And then C squared equals 1 squared is 1. 3 squared is 9. C squared equals 10. So C is the square root of 10. That's actually the exact value. The only factors of 10 besides 10 and 1 are 2 and 5. Neither of those are a perfect square. I wasn't given directions here, so this would be the exact value. And then to the nearest tenth, to the nearest hundredth, whatever the directions may say, the directions didn't say. So I'm going to actually write my answer 2 different ways. Then if I round it to the nearest tenth, the square root of 10 is about 3.16, or then about 3.2. So depending on what the directions are, would depend on which one of these I want as my answer. Exact value, approximation. But that's finding the distance from a given point to a line.